Of a recap of what's going on. You just saw the keynote. People are headed off to the lunch area right now, but we wanted to keep the content flowing for you so that you can actually hear from the people that are innovating here at Microsoft. Today we're going to talk about AI. I have the Corporate Vice President of the AI Platform, Eric Boyd. How are you doing, my friend?
I'm doing well. Thank you for having me.
And we have Chris Lauren as well, Principal Program Manager on the AI Platform. How are you doing, my friend?
Fantastic, thanks.
Well, it's so good to have you because, first of all, I'm all about AI. You probably know that. I love AI and I think it's great, but I feel like for some reason it's a little mysterious. So why don't you give devs a sense for what AI actually is and how we're helping them as a company?
Absolutely. We've AI does get built up as this magical box where some scientist and researcher does some incredible thing that makes this incredible technology work. And in reality, it's a much simpler process. You need to figure out how do you take a large amount of data with some examples of, hey, this is a good example or bad example, and then train a model. And train a model also sounds really hard and like, do I need to have a PhD in calculus or something? It's really pretty straightforward with the tools that we have now. You can basically train this model just straight away using the tools that you have, the Visual Studio tools for AI, Azure ML, lots of the things that we provide, make it really straightforward. And so, what is AI? I want to predict anything. I want to predict housing prices. I want to predict how much water is left in this cup. Anything that I might want to predict, if I can find some samples and I can train a model, it's going to go so much better than trying to come up with a heuristic or doing it that way yourself.
Awesome. So Chris, what are some of the tools that we're building to help developers do this? And me and Chris work together a lot. In fact, I think we have a session on Wednesday. I keep saying Thursday for some reason. It's making you nervous, right?
I'm going to write a classifier to determine whether Seth shows up on time.
Good luck. Okay, so tell us about the tools that we're building to help developers make these kinds of models.
Sure, absolutely. So we've invested heavily in making sure that we've got a great Python SDK using Azure Machine Learning to train models in the cloud. That's for data scientists. For developers, we're also making it super easy to grab these trained models, whether they're pre-trained models that are available on GitHub, downloaded from the Azure ML Model Gallery, and add those models, whether they're TensorFlow models or Onyx models, into their applications super easily, generating C# code and building their apps just like they would any other kind of apps, but now they're infused with that intelligence that makes them the next generation of applications that are really fun and enjoyable to work with and do things that you never could write the code to do without those models.
So we keep saying the word models a lot. What exactly is a model and how are they built?
Sure. So a model is basically just the description of how you're going to make your prediction. So if I want to predict a housing price, I have a whole bunch of inputs like the square footage or the number of bedrooms, and then I feed that through the model. And so the model is just sort of saying, how do I multiply this? What functions do I apply to this? What different weights does it learn? And then that outputs a prediction of this is what the house ought to be worth. And so that's what the model is. It's effectively the software that you just produced that will create a prediction for you. And the magic of AI is that you can come up with this really incredibly large model that you don't really understand how it works, but because you can train it and because you can use the AI training algorithms and it does the back propagation for you, it actually learns what are the best weights to provide predictions that are way better than you could possibly do on your own. So that's what a model is. It's just the output of what you've just trained. It's your AI predictor.
So as a programmer, when you're thinking of a model, should you think of it as an asset or a unit of execution? I mean, what are we thinking about?
So you should think of a model as essentially an intelligent library or like a function that you can add that does something like a skill. It's a library like creating PDFs or anything else that you simply add to your application and then call it and pass in some input and you get some output. In this case, it might be the prediction of the house price or something like that. And so that asset is something that you would treat something that you would want to update over time, just like any other asset that you would use. You've got to version it, you've got to deploy it, you've got to run it somewhere, whether in the cloud or on the edge in your app, on your device.
So as we're talking, by the way, please, we have the questions open, so please ask us any questions you want. They will answer them graciously. So let's talk about the training process, because now the way I'm understanding it is we have this process where you build a model, and that takes some time, and then we have the process of using a model, which should be faster. So we should separate the two, right?
Absolutely.
So let's talk about the training process, and what are some tools in Azure that actually help us with training?
Sure. So, when you're training a model, that's can be one of the most expensive steps in terms of how long it takes and how much computing power it takes. And one of the real advances in the last, few years in machine learning is all around how GPUs have been able to dramatically accelerate this training time. And so things that would take hours and hours and hours to train on a CPU, now you can use a GPU and it'll go much, much faster. And so on Azure, using Azure Batch AI, you can get access to lots of GPUs that we have available. And you can use, some of these algorithms will help you distribute the training to even more GPUs. So if you have a particular algorithm or a particular data set that's even larger than that, then you can use distributed training to go and train them on there. So that simplifies things dramatically. Other things that will help you with the training process, a lot of times you want a model that does something that's similar to what other people have already done. And so we just announced today the Azure machine learning packages, there's a vision package, a language package, and a forecasting package. And so, those will sort of help you with, here's the framework and the scaffolding that you need for training your model for something, you can kind of take something that already exists and go and iterate from there. So those are just a couple of the things that we've offered. And really, we have a complete platform to really dramatically simplify all the things that you might need to do in the training process. Everything from how do you prepare your data? Scott walked through a lot of the Databricks things that you can do, to then how do you train your model and how do you use Azure ML to sort of manage the training. And there are a lot of steps in it that can get really quite complicated. You'll hear people talk about hyperparameter sweeps and things like that, and man, that sounds pretty hard. We have tools that will manage all of the hyperparameter sweeps for you, and you don't even have to think about it. You just sort of say, yes, I want the best model I can get. Please go and do that for me.
So really, you don't even have to, it's good to know this stuff, because I love it. I think it's great, that I'm fascinated by the math, I'm fascinated by the models, but if you're not, we have tooling that will help you take care of that for you.
Absolutely. I think about it, machine learning is going to turn into the thing that you take a class in college. When I was in college, I took a class on compilers. I wrote a compiler. It was the hardest class I think I took in college. And I've never written a compiler since, but I use them all the time.
Right.
And so the understanding of how does it work and this having that background is pretty helpful. And I think that's what AI is going to turn into is you got to understand, well, how does backpropagation work and what are you doing with the model? And when you're training, what are the different things? How does regularization help you? All the different things. That's important to know. But as you use it every day, the tools are going to abstract all that away from you. So it's good to know. It'll make you a better developer the more you know. But it's going to get much, much simpler. It's going to become ubiquitous. AI, everyone needs to be developing it. If you haven't started on it, go get started.
Maybe it might be a little too late, but we have all the tools to help you get started.
I don't think it's too late. I think this is, we're day one of a giant industry, but I think everyone needs to be jumping on it.
Awesome. So what tips do you have for devs that want to get into this space?
The easiest way to get started is to use pre-built capabilities like our cognitive services in Azure. You can build amazing image classifiers. If you have some sample images, or you can download some sample images off the web that say classify the difference between is this soda or is this beer, for example. You can just grab a bunch of images, put them in two little folders on your machine, and use Visual Studio Tools for AI that even generates code for you. That'll upload that data to the custom vision cognitive service, train a TensorFlow model, and even download that model to include in your application, or don't even worry about that and just call the model directly in the cloud. So you don't even have to write code. You just have to have samples of data and an idea as to what you want to predict, and you can let the Azure AI platform take care of the rest for you.
And that's kind of cool, because now that I'm thinking about what you're saying, you're talking about models. We have models that have already been trained that you can just call right now, cognitive services.
Absolutely.
We have models that you can customize a little bit with things that we understand. Like, for example, custom vision or Lewis or whatever. You should just start with those first and get comfortable with it.
Absolutely. I mean, as a developer, I always focus on productivity. And if I just want to sprinkle some AI on my app and it does the job for me, that's fantastic. But sometimes I need to go a little bit further, say, okay, I want to tweak the model a little bit to do something that it didn't previously do. Then I want to take the next step and customize that model. And then if I am super interested in learning on how it works, then I can absolutely use some of the samples that are online through the Azure ML Samples Gallery, download some sample code, and train my own model from scratch and really get a feel for how the code actually works.
Awesome.
And I was going to say, there are lots of examples where if you're trying to learn this stuff, you can go to Azure Notebooks, and within Azure Notebooks, there are Jupyter Notebooks that are hosted in the cloud for you. And Jupyter Notebooks, for those who haven't seen them, are great ways of sort of walking through and learning something. It mixes the code with sort of the text explaining and sort of the output graphs on there. And so they're great tutorials. I took a bunch of them to really get ramped up on how do you do some of this, like if I wanted to do transfer learning, well, let me go look at the Jupyter Notebook that explains this is what transfer learning is, this is how you do it, this is why you do it. There's a lot of great resources that you can use there.
That's amazing. So for those that are getting started, you're saying take a look at cognitive services, take a look at notebooks. For those that want to get more involved in AI and want to get into maybe the fundamentals or want to start working on something, what's a good way to get started?
I mean, if you're talking about sort of becoming the AI expert, which is, where people need to be heading, you need to learn sort of what are the basic things that people are going to try and do with machine learning, and so build those. The image recognition, build your own face recognition, just sort of playing with those types of examples. It'll get you familiar with, all right, I have data, I have a problem I want to predict, and now I'm going to train a model, and I'm going to execute and use that model. You'll need to learn a framework. You learn PyTorch just came out with 1.0, and we partnered with Facebook on making that really simple and easy to use. And so learn that as a really great, easy to start with framework that then will give you the tools to sort of put the layers into your model and build it together. So if you're looking to get deeper, those are the areas that I would look to dig in more into.
Awesome. Well, let's dive into a question that just came in from Ryan McDonald. When you're referring to these predictive models, how accurate in terms of percentage or ratios have the results been from these models? So how good are these models that we're asking people to just use?
That's a hard question to answer just sort of in a straightforward manner. Some models are remarkably accurate. There's a model that we'll talk about later today where a team of researchers at Stanford took a bunch of chest x-rays and labeled them with doctors' predictions of diseases and trained a model based on that, and now we have a very accurate model that given a chest x-ray can predict how well that's done. There are some things that turn out to be pretty hard to train models against entirely, and so that's part of the model building process, is to try here are the features that I have and train my model and see how well it does. I mean, we talked about housing prices. You can go to Zillow, and everybody does, and looks at how much their house is worth. And how accurate is that model? It's pretty good.
Yeah.
I'm not going to set a price based on it, but it's pretty good. And so, but it's the critical things to it are having the right inputs into it. The first time I tried to build a housing price model, if all you have is square footage and number of bedrooms, you're going to do pretty terribly. And so, it's all about having the right inputs into it, the right features, and then making sure that the model can learn. So in some tasks, it's fantastic. You saw us talk about, the Stanford Q&A today where we set the record, with the machine translation where we're at human parity. There are a lot of things where it's just fantastic. Some areas where there's still more to come.
So what I'm hearing is that AI is not magic because it's only as good as the data you give it.
Absolutely. That's one of the big challenges, is finding the right sets of training data, and almost every important AI model needs labeled data. And so labeled means some person went in and said, this is a good answer, this is the price of this house, this is sort of, and so given all the features, here's your label. Coming up with labels is one of the hardest parts of machine learning. If you have a great set of labels, you've got a great model that you can go build.
So a lot of the work in AI really has to do with looking at what data you have, knowing what kind of questions you want to ask, and then building great models or using models that are already built.
Absolutely, yeah.
So here's another question coming from Jonathan from Ottawa. All I hear about is TensorFlow. Can that run on Azure? Chris, I'll let you take that one.
That's a fantastic question. I run TensorFlow on Azure just about every day. In Microsoft, we absolutely have invested in tools and frameworks alike. We use CNTK extensively inside Microsoft. We use TensorFlow inside Microsoft, and a lot of us use PyTorch and other frameworks as well. There's absolutely nothing specific about our tools or platform that preclude using any particular framework. We're all about productivity and empowering every developer out there to infuse AI into their apps, and absolutely love TensorFlow.
And I'll just add on with that. As we think about AI, we really want to see AI be open and open for everyone. And so, with that, we've really embraced all of the different frameworks that are out there. That also drove, we did a partnership with Facebook and Amazon and a whole host of people, Satya mentioned it, called Onyx, which is an exchange format so that a model in TensorFlow can be converted into any other framework and then can run on any hardware layer. And so we think the acceleration that the industry has seen from being open and sort of embracing all the different technologies and making tools that work together is really important for the industry, and we're very committed to it as a company, and Azure supports all of that.
And I think it's cool because I feel like in AI we're moving from the assembly language, now we're getting into languages, and
That's
even
right.
we're getting into tooling around that actually makes AI a lot more accessible, it feels like to me.
That's right. I mean, if you look at anything that's hard and complicated, what do we do as computer scientists? We wrap some abstraction layer on top of it. And so, at first people hand wrote their models, and then they added these frameworks which are making that simpler. And now the frameworks themselves are getting simpler and more interoperable, and the hardware is getting abstracted. So this is what we do. It's what we do for a living, is we make things that are really complicated, really quite simple and easy to use.
And to give an example of that, we've included in Visual Studio Tools for AI a simple UI where you can grab a TensorFlow model that's been trained, convert that into an Onyx model, and then even generate the C# code automatically that then say you use in an Azure Function project and deploy that and do serverless scoring in the cloud. So we can just continue to make this easier and easier.
You may actually see some of that in Harry Shum's talk. Not spoiling anything, you may see it.
Stay
Actually,
tuned.
right,
I'm excited.
Yeah, stay tuned. All right, another question. From Richard Freitag, is there a .NET solution where the data used to learn an AI model never leaves our local premises?
Sure. So a lot of our tools you can train locally. We actually think the Surface Book is one of the best AI tools out there, because you can take a Surface Book which has a GPU processor built into it. You can load your data onto your Surface Book. You can run Visual Studio Tools for AI, a plugin that you can go and add to your existing Visual Studio tools. You can run all of these different frameworks, and you can train it locally right there. If you're in a corporation that has a firewall and you need things to stay local, all of this stuff again will work locally inside of your existing environment. The challenge that people run into is that often they want more compute, and so if they want that, they often want to send it to the cloud, which helps you scale up, but there's nothing limiting you. You can run all of this stuff locally in your environment if you like.
Awesome, so we're not like hampering anything, it's just literally, this is just code, just run it.
Exactly. I mean, if you run Visual Studio for your, any compilation that you're doing, you can do that locally. You can use cloud resources to do that. It's the same thing with machine learning. You can do it locally on your device and train right there. But then you got to provide all the hardware, and buying 1,000 GPUs, I can tell you, I sent in the checks. They're pretty expensive.
Yeah, I asked my boss to buy me 1,000 GPUs. He laughed at me a little bit. All right, Gisela from Germany, the keynote showed a bunch of AI stuff on devices. How do I get my custom model on a device? Does it work on all devices?
Sure. So that's what Satya was showing in that keynote, was showing the IoT edge packages that we're releasing. And so with that, what you do is you take your model and you train it as an AI model, and then you deploy it in a container. And so we have the IoT edge support, has Windows and Linux device support. So you need a device. It has to run an operating system, Windows and Linux both, and has to run containers on it, which virtually all of them do, and then you can deploy it and run it right there. So it's really very simple to do.
I'll also point out that you can build Xamarin apps to deploy models to iOS and Android included in your app, just like you would include any other resource. Right-click, add existing item, and include your trained model. Using the power of Windows ML, also, we've added capabilities in Visual Studio where you can simply add your Onyx model, and it generates your C# app code for your application as well, that then deploys onto the Windows as a device as well. So devices have a lot of different form factors, and depending on what you're shooting for, sometimes containerization is really awesome, and sometimes it may not make sense. And so within Visual Studio, we've got a whole bunch of different tooling options to help you get done what you need to do.
All I know is containerization for me was when I understood and actually used it. Example, someone wrote a PyTorch model that I was supposed to operationalize, and it was a version of PyTorch that didn't work on Windows, and I have Windows. So what do? Well, I just put it in a container,
That's right.
ran it, everything worked perfectly. I'm like, oh, okay, now I want to put this on a Linux box, but I want to have GPU support. Oh, I just say inherit from a different container or a different operating system, and then it worked on a GPU. It's pretty amazing how you can do this stuff.
No, it's really simplifying. It's another one of those abstractions that we build, and so simplifies the management and deployment of all of your different models. And so you can run them in AKS, Azure Kubernetes Service, and run them in the cloud, or you can run it on a device that you deploy to thousands of users all across the world.
Awesome. So we only have about 8 more minutes left, roughly. There's tons of questions. Robert Poplin, for us newbies, does the Azure platform support scikit-learn?
Absolutely, we definitely, as we say, we embrace all of the frameworks. Scikit-learn is one of the most popular, what you would think of as classical ML frameworks, and so you can definitely use scikit-learn. We use it all the time here.
So go ahead, sorry.
Yeah, I was going to say, one of the easiest way to think of like the Azure deep learning VMs or the Azure VMs generally, it's just a remote development environment, and so you can log in to an Ubuntu or Windows machine and do any kind of development you want there. And the deep learning VMs in particular come pre-installed with TensorFlow, CNTK, and more. Jupyter notebooks and everything ready to go. You can have it spun up in a couple of minutes with a really powerful Azure GPU VM that you log into and do any kind of machine learning or deep learning you want there, and then spin it down when you're done.
I see, and I think that goes to the heart of the questions. We've got a lot, hey, can I do this, can I do that? You're literally renting a machine that's very big, and then you're running your things, and then you're turning it off when you're done, and you're not paying for it.
And all configured and set up with all of the frameworks and libraries that you would want. You don't have to go and install them and pip install this and that. It's all ready to go right out of the box.
And if there's a framework that maybe someone's working on, they can just install it because it's their machine they're renting, right?
Absolutely.
Yep.
Okay, so you can run almost anything. All right, next question. Jesse, what sort of investments are you making in Cognitive Toolkit?
Sure. So Cognitive Toolkit, which we often internally still call CNTK, is a framework that was developed internally at Microsoft by the speech team and is just fantastic for RNN, recursive neural networks, and recurrent neural networks, and things like speech work tremendously well with CNTK, and so it's an important framework that we continue to support and invest in. There are a bunch of we release it basically every month. There are new features that are coming out all the time on it.
Awesome, awesome. All right, next question. How many annotated image samples would you need in order to be able to identify foods such as hot dogs or not? I added or not.
The classic. That was Silicon Valley is a fantastic show. The number of images often depends. There are a lot of tricks that you do where you take an image and you scale it to different sizes and you rotate it. And so you can take a single image and actually turn it into probably 20 or 30 different images. Of course, everyone tries their own. After that show came on, I tried to train my own hot dog or not hot dog. The nice thing about that is you can just go to Bing image search and search for hot dogs. And I think I grabbed 100, 200 images and sort of grabbed those down. It's really pretty easy to find images of a hot dog, and then just trained a model on it. And mine wasn't great. It worked okay, but
well.
But
it's only as good as your data, right?
And even with a small data size like that, you can absolutely use the pre-trained custom vision cognitive service, upload a bunch of images of hot dogs, 10 or 20, upload 10 or 20 cupcakes, 10 or 20 hamburgers, and it's going to do a pretty good job because it's already learned on another model in the cloud. And so the high-level features and the understanding of the objects around it is already there. So it just actually takes a couple seconds to sometimes a couple minutes to customize it to then produce that classification, hot dog or no hot dog.
Yes.
Awesome. Okay, so we only have about 5 or so minutes. There is this, like, a lot of people ask me questions, like, I want to put AI in my application, and I don't even know what that means, right? What does that mean? There's an interesting boundary between writing regular software and doing AI software. Can you try to describe where that is so people might get a feeling for like, oh, maybe I should use AI for this, or maybe I've been doing it wrong. What is your sense for that?
I mean, is your question where should you use AI?
Yeah, like how do you know, like, hey, this problem is perfect for AI?
I mean, in general, what AI generally does is it makes a prediction. And any place where you're making a prediction, you probably should be using machine learning. And so that sounds pretty vague, or help me out with that a little bit. Anytime that you're trying to decide, all right, I need to, like we do this in Azure, I need to allocate some resource to which VM should this particular job run on. We have some heuristic, we round robin through them or something like that. AI is going to do a much better job at things like that. Images is a fantastic place for AI. If I want to do any sort of image classification, is this a hot dog or not a hot dog? Is this a face? Anything like that. That is a great problem for doing machine learning on. But the thing I'm really encouraging people is every part of their application, just look for the place where you're doing prediction. We work on a lot of platform things, so a lot of the things that we end up doing are, how are we going to make this resource really efficient and fully utilize it? And so placement policies and allocation and things like that, quota policies, all of those things are often done just with a rule, and a rule is never going to perform as well if you can train a model on top of it. And so that's my encouragement. Any place where you're predicting anything is a good opportunity for that.
I see. So if you have like a heuristic that you wrote and you keep having to fix it every week, maybe you should look to data and have that actually do the heuristic.
And one of the things that's really interesting about AI is it's really making prediction cheap and easy. And so what people are doing are taking problems that don't look like a prediction problem and turning them into it. So if you're talking about, I have my self-driving car,
right.
That's a prediction problem. What should I do? Should I turn left? Should I turn right? Should I go straight? Because we can make predictions so cheap with AI. And so any place where you can think about, hey, I can change what I'm saying in terms of a prediction problem, that's going to be a better outcome.
Awesome. All right, some questions here. What about the shift away from data sets post GDPR to model-based AI? Like, is GDPR a problem when it comes to AI? I don't understand GDPR that much,
I
to be honest.
think I know way more about GDPR than I ever care to know. So GDPR is a set of regulations in Europe that regulate permissions that users have on top of their data. And so how is that going to impact AI? AI works best when you have a lot of data. The main things with GDPR, though, are you need to be open and transparent with your users. How am I collecting this data? How am I using it? And get their permission to do that. If you do those things, you're not particularly limited in terms of how you use their data. But the other thing that comes up is oftentimes you'll use a lot of data to build a model. And so that model now sort of has aggregated information about really the entire world's information. And so that model doesn't actually know anything about your actions. It knows about users in general's actions. And so you can use that as a good way to make sure that I've learned and abstracted the details from something without actually having any personal information about the user. And so there is a lot of that going on.
Cool. All right, a couple more questions in the last 2 minutes. What about the data? All my organization's data is hosted in legacy systems and warehoused on premises. Can I leverage Azure ML without migrating all the data?
That's a non-straightforward question. Very hard to manage data. That's one of the, when you think about all the work that machine learning scientist, data scientist does, there have been lots of charts drawn where they'll say, this is all the work, and this is the training part right in here, and most of it is managing and wrangling the data. You absolutely can use Azure ML and Visual Studio Tools for AI and other tools with your existing data wherever it is. That said, just because you have data, will you be able to use it effectively? You probably are going to need to do some work on it.
Awesome. So another question, could developers sell trained models on the Azure store?
I'll confess, I'm not really sure. I don't think so.
Currently, no. However, we have just launched the Azure ML Model Gallery, which is the first start in that sort of direction. We haven't talked about the monetization aspect, but AI is this super interesting time where people are sharing code. They're sharing models on GitHub and other places. And we do have an Azure ML Model Gallery that you can download Onyx models. They're even annotated as to which are compatible with WinML and which aren't. And we will work towards opening that up so that people can publish their models. And then the monetization aspect is something that we'll discuss in the future.
Yeah, we're engineers right now.
Absolutely. We're just helping people get stuff done.
Awesome. Well, thanks so much for spending some time with us. We got about 30 seconds. Coming up next, we have IoT with Sam George. I believe you saw him in the keynote. I'm pretty excited about that. My manager, Tim, is going to be taking over. Thanks so much. Anything you want to say just to finish up? What should people go look at right away?
I think we announced a whole bunch of great things today that people should go check out. You can go to azure.ai and see a whole host of things about the cognitive services that we've got, about the Visual Studio Tools for AI, all the sorts of things that you can go and use. I think AI is super exciting. Go check it out.
Awesome. 5 seconds. What do you got?
Go become an AI developer today.
Love it.
I mean, it's super exciting.
Love it. Thanks so much. We will be back after a short break while we reset our stage with our new guests. We'll see you after this break.